we'd like to talk about our tabletop exercise. Dark Winter is a famous tabletop exercise against smallpox bioterrorism. It was created by Johns Hopkins University, United States. This is a very, very famous one, like this one. Well, assuming a standard scenario for infecting process. And of course, this is the typical type of tabletop exercise. So they playing, so mass media and the president and then so on. So this is a role playing in the realistic situation for learning this bioterrorism situation. And this is only one scenario of infecting process. But we introduce new concept, simulation supported tabletop exercise or simulation supported hybrid simulation. So that gives better shared intersubjective internal model for our society. It is better than implicit model in brain. So social and organizational communication, discussion, learning, understanding, and decision making should be supported by simulated internal model, I'd like to say. Okay, so this is a real example. This depends on my bioterrorism and anti-smallpox simulation. And this is our tabletop exercise by professional. So consultant and National Police Agency and vaccine production company and National Defense Agency and other stakeholders came together. It was held Global Security Center at Keio University, 2008. So, anti-bioterrorism simulated tabletop exercise. And this is not for oracle, but for clarifying and evaluating a possible option of scenario. And also for discussing the model's validity itself, because so many stakeholders come together, professional. And in this model, we have distinguished 216 scenarios. And this is the structure of gaming simulation for our tabletop exercise. We constructed 4 teams. Each team determines some scenario on this virtual city. So actually, city scenario and the pathological scenario and the policy scenario, there are so many scenarios in the simulation. But in this case, we only focusing on policy scenario. That means a vaccination scenario and filter policy scenario and the school and office shutdown scenario and then so on. And actually, we distinguish 6 categories of scenario. Vaccine stock. So, 30%, 60%, and 100% of population, 3 types. School shutdown, yes, no. Number of vaccination per day. Vaccination speed, 2 scenarios. Delay in commencement of vaccination, 3 types. Targeted generation for vaccination, old or young, 2 scenarios. And targeted social network for vaccination, 3 scenarios. So, social network scenario means, vaccination for infected person and its family member, and if he is a student, a school member, or he is a worker, office member. And this scenario is called red. And yellow scenario is also office members, family member, or school members, family member, or families members, school member, or office member. So it looks like a ring vaccination scenario. So we prepare the following card for each of 6 scenario factors for selection. And for gaming or tabletop exercise, so 4 teams select these cards by order. So, by this order, this is the Weber method, selecting method. Then this is our scenario. Scenario 1, 2, 3, 4, 216, and determine scenario. Then, in my simulation, select the scenario number and run. Then, this is our reproduction rate. This means how many people have infected average by one patient. So in this case, max 7 persons were infected by one patient. Okay, this is a typical one. So infected and non-infected and then so on. And this is a 4 scenario selected. And this is the debriefing process of this simulation. In this case, team A, team B, team C, team D. So actually, not so good one and worst cases, and maybe best cases. So enough vaccination and high-speed vaccination and school shut down. This is the best cases. And worst cases, well, not worst, but very bad cases. Vaccination stock is 100%. That's okay. But vaccination speed is very, very slow. Then cannot protect the society, and then so on. So after that, we can discuss with a professional. That scenario is okay, or is this realistic or not? Anyway, so we can discuss and discuss and discuss. And then we can share the information and the internal model. So simulation model itself is actually realistic or not. It is important, but not so critical. Okay. And also, this is, we say, so we simulated all 260 scenarios by SOARS grid. Then we found, so this axis means the total vaccinated, number of total vaccinated person. And this y-axis means, total infected person. And this point, each point show each scenario. Then we can easily notify, okay, so many people are vaccinated. Then, not depend on another scenario, risk zone is very, very limited. But if the number of vaccinated people is limited, then depending on the scenario, risk zone is very, very wide. So in critical situation, maybe we can fail some, some political decision. In that cases, vaccination is a very, very easy way for preparing. So classical epidemiology says, vaccination is the best way for avoiding our pandemic risk. Anyway, so this type of landscape analysis is also very, very important for social simulation. Actually, so many people emphasis on the importance of sensitivity analysis in simulation. That means change the initial value and seed. But change the boundary condition, so total boundary condition, to show the all aspect of boundary condition. We say, so we say this is landscape analysis. In standard mathematical dynamics, dynamic trajectory analysis, initial and boundary condition is very, very important. But statistical analysis, structural change and bifurcation analysis is very, very important in standard mathematical language. In social simulation language, of course, to understand the dynamics, simulation, sensitivity analysis for initial condition and seed is important. But more important thing is just structural analysis. For that purpose, landscape analysis is very, very important. Simulate the whole structural parameters that determine the possible scenarios on the model and analyze the structural sensitivity for the parameters. That's important. In the case of tragedy of commons, so subsidy and tax policy are well, structural parameter in that cases. But well, so what is the structural parameter for analyzing that well, model? That itself is a very, very important question for making the model. Okay. Anyway, so social simulation language create a social simulation model as a cluster of concepts, such as the epidemic infection model, that gives the dynamical ideal type and support to understand the dynamical change of the social phenomena by showing a possible scenarios explicitly. But well, sometimes social simulation might create a simulacrum instead of a proper ideal type. So simulation or simulacrum, that's the problem for us. Okay, so for that purpose, we need a real-world investigation. Actually, in not a smallpox case, but swine flu cases, we have investigated Izuoshima, small island near Tokyo, and only 5,500 people are living that. And this is the real investigation. Actually, we have a 2.5 year investigation at Izuoshima. So, and we have detected microepidemic curves that are corresponded to our model layer, not a macro, but a mesoscale modeling. And micro outbreak concept we have investigated in Oshima field work, like this. Okay, now go back to agent-based modeling and simulation methodology. Okay, we introduce the concept of IIR.
I'm wondering, do you have recovered this modeling the boundaries? Is this much longer? Because I'm wondering if we should move right here and move back here.
Okay.
I think that would be best, because I really like this material.
Okay, now I'd like to explain about the methodology, then the break and discussion.
Yeah.
Is that okay? Example and methodology, then discussion and conclusion.
Well, actually, I didn't want to cut it short. I wanted you to come back.
Yeah.
Because I think both of them are so rich. The first part about agent-based simulation, the second part about unfolding the boundaries of the model.
But unfolding means a connection of micro model and macro model.
So this gets to these
Actually, we're strongly connected to. Okay.
Tell us so we can plan how much more time.
Oh, yeah. Time.
Another 5 minutes?
Maybe 15 minutes. Is that okay?
We'll try to make it.
Okay. Actually, I don't know exact time schedule well. Anyway, okay. Maybe I cut some part. Anyway, so any model has its boundary condition. And any model has its limited validity depending on its boundary condition. So, and we introduce the concept of model unfolding and